All of us are fascinated by the incredible images and films of volcanoes throwing out huge amounts of ash into the atmosphere, or rivers of red hot lava finding their way through anything lying in front of them and not stopping until they have flowed several kilometers. How some of the lavas manage to reach distances of tens of kilometers. Today we will try to answer this question with the help of melted wax and get a closer look at the emplacement dynamics of some of such flows. Before proceeding with the experiment, it would be helpful to understand volcanoes better. Volcanoes erupt in various styles, and they are broadly categorized into two types, explosive and effusive. In explosive eruptions, explosions lead to the formation of ash clouds or plumes, while in effusive eruptions, lava flows down the flanks of the volcano without any major explosions taking place. Whether an eruption will be explosive or effusive depends upon the composition of the magma as well as the amount of gases. Lava flows too can be classified in various ways and affected by various factors. For example, viscosity, rate of eruption, temperature, chemical composition, slope and shape of the underlying terrain, the temperature of their surroundings, etc. In this experiment, we will be observing two types of lava flows, namely compound and simple. They are differentiated by the presence of flow units. Flow units are separate discrete bodies of lava with a hardened outer surface. Their size can range from 10 centimeters to several meters. A compound flow is made up of multiple flow units. When one discrete batch or unit of lava has flowed, its surface solidifies and hardens very quickly. This hardened part is called the crust. This acts as an insulation to keep the lava sufficiently hot beneath. Further influx of lava inflates the flow unit like a balloon. After a certain degree of inflation, the liquid lava bursts through the crust and forms another flow unit. This process continues until lava is being erupted. And since the lava inside the core remains hot, it can create very long flows given that the duration of the eruption is large enough. On the other hand, simple flows are sheet-like flows of lava, which can't be clearly divided into discrete flow units. The most common type of compound flows are Pahoehoe flows, consisting of bun-shaped lobes of lava. Such flows are usually produced when the eruption rate is sufficiently slow. Lavas with a relatively high viscosity and a huge velocity form Pahoehoe flows, which have a very uneven and clickery surface consisting of irregular fragments of broken crust. Such flows can be either compound or simple, depending upon their velocity and rate of eruption. Now we will do an experiment demonstrating the characteristics and features of Pahoehoe lava flows. We need a piece of wood, a tray made up of aluminium foil, a candle, and few pieces of wax. We can light the candle and place it under the tray in order to heat it and melt the wax over it. The wax pours onto the wooden surface and flows like a Pahoehoe flow. Make sure that the angle of the wood is less enough so that Pahoehoe lavas are formed. This highly resembles the Pahoehoe lava flows which we can see in the Hawaii or Icelandic volcanoes. We can observe how the several flow units of wax flow just like compound Pahoehoe flows. Several such flows can form a flow field. We can observe how the lava flow proceeds by addition of more lava inside its core. An intricate network of Pahoehoe lobes and toes, and even some simple flows are formed. Explore our flow field formed with the help of wax flows. Can you identify simple flows, Pahoehoe flows, toes, lobes, and some other shapes in it? They closely resemble the Pahoehoe flows we can see in Hawaii. For example, this is a photograph of cooled Pahoehoe toes in Hawaii. This is the cross-section of a Pahoehoe flow in the Deccan Traps of India. We can see approximately 2 big lobes of lava. Thank you very much. You can explore further in the experiment by taking different types of wax, varying the slope of the wooden plank, and changing some other constraints. Thank you once again.